Everyone, Alicia Panzarella here, taking a look at my inquiry activity for our capstone project. Well, my inquiry activity is not going to necessarily discover content, rather it is going to apply content in a way where students are going to identify a real world problem dealing with rotational motion, and they're going to design and innovate a device to solve that problem. So one of the reasons that I decided to do this type of problem kind of goes back to module 1 and where we looked at, what STEM approach do we think is in our classroom now? Where do we want to be? And this is where I've always kind of wanted to be. I wanted to have an approach or a course that really just integrated all of the 4 aspects. So by designing a device, they're not only going to have the physics behind it, which automatically has math, but they're going to have that engineering process, and then technology will be there in some form, whether it be in the lab portion, whether it be in the 3D design and sketching, but it will be fully integrated into this project. So this was my goal from module 1, and hopefully this activity is going to help reach that goal. Now, what they're going to do is they're going to identify, like I said, a real world problem that deals with rotational motion. So the students are saying, this is the question that I have, this is the problem that I think exists, and how can I solve that problem? So it's very much so on the students to form the hypothesis, find the problem, do the research, do the lab portion that's going to help them solve the problem, and ultimately design a device. So it kind of has all of those inquiry pieces involved. Now, like I said, I did want to have this in the deployment stage of the unit. I think the modeling approach does a pretty good job of using guided inquiry in order to discover content, but I felt that I was really lacking in the deployment stage of still having that inquiry. I had a lot of application, but not as much inquiry. So this is why we're seeing this at more so the end of a unit rather than at the beginning, applying all of their knowledge of rotational motion, but in an inquiry setting. So as I designed this activity, I really used the inquiry matrix more than I actually thought I was going to. I designed the activity, and then I did go back to say, okay, well, where am I on the matrix? And I found that I was missing a couple pieces. So this was really, really helpful to get to that most complex side and really have a more full activity that I had originally thought. So two of those places, there we go. Two of those places first looked at the lab portion. When I originally thought of this activity, I thought that the research and the statistical analysis would be enough. But after looking at the inquiry matrix, I realized, hey, we really have to have a lab investigation. So that was put into the activity, as well as presenting the information to the class. It's kind of like a Shark Tank. My original thought was to just have them turn it in like any old project, but that would not have done the inquiry process justice. I do think after looking at all of our resources in this class, that having that final presentation stage where there's then the discussion is a really important part of inquiry. So I added those two things after looking at our different resources. All right, so I personally did this project. I didn't have the lab portion when I did it. However, I did have all of the rest. So I identified a problem dealing with rotational motion that looks at torque and changing a tire in the event that your lug nuts are over torqued. So what do you do when you don't have a lug wrench that is big enough to get enough leverage, get enough torque to actually get your tire off in the event that you have a flat tire and you don't have any other means of changing it other than yourself? So here's some statistics that I had. So some of that background research information. What is on the market now, which is one of the things that the students are going to have to look at. And then ultimately, here is where I applied the physics. So how much torque is needed for an average flat tire? What happens if it is over torqued? And here's all the math that would need to go into, hey, how can we solve this problem? So here's the physics, here's the math being applied. So I did test this theory. This is where I would actually want to have that lab portion if I were to do it right now. And then I have the sketching portion where I designed the device. So here is all of that for my interlocking lug wrench. And then cost of materials, which is something the students may or may not do. And then I had a secondary portion where I use a spring coefficient, but the students may or may not use that. But you can kind of see very quickly what was put into this project. You know, I had the research, the statistics, and the actual design of the device, which use the physics and mathematics principles. So that is really my goal for this. I'm very excited to put this into action for next year and see how the students do with this open inquiry process.